Good afternoon, everyone. This is Gavya from 3rd BCAC. My topic is about detecting blindness occurrence in diabetic patients. First, we are going to see about the introductions. Blindness and severe vision impairments are the significant global health challenges affecting the million worldwide. According to the WHO, World Health Organization, over 2.2 million individual experiences some from of vision impairments. Among the leading cause of a preventable blindness is the diabetic retinopathy, which is an DR. It is a diabetic related complications that damages the retina due to the prolonged elevated blood sugar levels. The global rise in the diabetics prevalences has significantly increases the burden of an DR, establishing its cities and curial public health issues. DR primarily impacts the retinal blood cells, causing the complications requiring the skilled personnel and specialized equipment. Innovative approaches, particularly those leveraging the AI, which is an artificial intelligence, and DL, which is a deep learning, have embraces to address those challenges by automating the diabetic retinopathy detection. Recent advantages in the artificial intelligence enable the development of systems that analyzes the retinal images and accurately classify the DR stages using the labeled data sets. These systems promise to improve the early diagnosis, optimizes the treatment strategies, and enhance the patient outcomes. One notable example is the ATOPS 2019 blindness detection innovative, which employs as the AI artificial intelligence driven techniques to classify the retinal images based on the diabetic retinopathy. By utilizing the conventional neural network, which is an CNN, a type of deep learning model which is designed for a image analysis, and the project identifies the patterns associated with the different stages of a diabetic retinopathy. The integration of an artificial intelligence in diabetic retinopathy detecting offers several advantages such as scalability for large scale screening, consistent and objective analysis, and reduces the reliance on human expertise, enabling the healthcare providers to prioritize the urgent cases. However, implementing the artificial intelligence based diabetic retinopathy detection system presents some challenges, including the need for high quality label data sets for modeling the training, techniques such as contract limited adaptive histogram equation and generative adversarial network, which is an GANS, can address these issues by enabling the image clarity and consistency. Collaborative effectives among researchers, healthcare providers, and policymakers are essential to overcome those obstacles. Ensure the broad adoption of an artificial based diabetic retinopathy detection systems. Building on a ATOPS 2019 blindness detection innovative, this study aims to refine an artificial intelligence methodologies for detecting the diabetic retinopathy risk by incorporating the advanced deep learning techniques and pre-processing methods to improve image quality. The proposed approach seeks to address limitation in the traditional diagnostic methods. By advancing the application of an artificial intelligence in healthcare, this study aims to contribute to the global fight against the preventable blindness and improving the quality for life for millions at risk. Next, we are moving to the existing and proposed system. This project is already existing. The existing systems. The traditional medical diagnosis where ocular ultrasound and OTC, which is the optical coherence tomography, and ocular ultrasound are widely used to detect retinal and optic nerve damages, obtaining the indicating blindness causing conditions. Automated retinal screening. Machines like Retina Cam or Easy Retina already integrated AI to analyze the retinal images and detect the conditions like diabetic retinopathy and muscular degenerations, which can lead to the blindness. AI powered diagnostic tools. AI for a diabetic retinopathy and gomonia detection. AI systems currently analyzing the retinal scans to identify the early signs of diseases such as the diabetic retinopathy and galvania, which are a major cause of a blindness. Public health and screening programs. Mobile and portable devices like Peak Retina app allows for a screening the eye using the smartphones, facilitating on the go detection for a potential blindness condition in the low resources settings. Proposed systems such as AI and machine learning enhancement diagnosis, mobile and wearable technology, IoT enabled smart vision devices, genetic screening and personalized medicine, tele, telephotometry and remote patient monitoring, behavioral and cognitive assessment. Next, we are going to the hardware and software requirements in this project. User management and authentication. Patient profile management, the software which allows the patient to register and maintain their profiles with the personal details such as name, age, gender, and medical history, family history of a blindness or a visual impairment and risk factor. Healthcare provider profile management, where the admins and the healthcare providers should be able to register, authenticate, and manage their profiles. Secure authentication. The system must support the multi-factor authentication and role-based access control to ensure the security and privacy of a sensitive patient data. Patient data collection and the management. Data entry forms which is able to fill in the forms detailing their vision history, symptoms like blur vision, image strain, lifestyle, smoking, diabetics, and meditations. Retinal image upload. This system must allow for uploading high resolution retinal scans or an image taken from the fundus cameras or optical coherence thermography machines for analysis. Vision test result, which allows entry and management of a vision test results such as visual acuity. Medical history record. The system allows the tracking of a historical patient data such as previous eye exams, surgeries, medications, and chronic conditions that may lead to the blindness. Diagnostic system. AI driven image analysis. The system should integrated with the machine learning models capable of analyzing retinal image scans and diagnosing the images to detect early signs of conditions like diabetic retinopathy, macular degenerations, or cataracts. Next, the risk of prediction and the alerts. The system should use algorithm to predict the blindness occurrence based on the data such as patient history. Real-time feedback. Upon analysis, the system should offer a real-time diagnostic result to both the patient and the healthcare provider, including the visual reports, telemedicine and remote monitoring. Here we have the teleconsultations between the patients and the healthcare providers for a remote diagnosis, remote data sharing, securely transmit the patient data including the retinal scans and test results and medical histories, continuous monitoring which continues all through the high health and provide real-time data on a vision changes. Integration with the external systems. Electronic health record integration. The software must be able to integrate seamlessly with existing EHR systems. Cross-system data sharing, facilitating the sharing of a diabetic data with the hospital, clinics, and other medical institutions to ensure the consistent care across the healthcare providers. Architectural designs. This study emphasizes the advanced deep learning techniques to classify the retinal images for blindness detection. The proposed framework is based on the effective net architecture and integrates the multi pre-processing steps to enhance the image quality and optimizes the model performance. The methodology is organized into the several stages is given below. Data input. Data input. To provide a high quality input data, a comprehensive pre-processing pipeline is applied. Image pre-processing, crop, blur, and enhance. In image pre-processing, image cropping, which is used to crop the images, removing the irrelevant areas such as the black borders. Gaussian blurring and enhancement, which undergoes the Gaussian blurring to highlight the structural details. Resizing. All the images are standardized to fixed resolutions. Color conversions. Images are converted from BGR to RGB to meet the pre-processing requirements. Data accumulation, which applies the random flips and the horizontal rotation. This technique, such as horizontal flipping and random rotations, are applied during the training to increase the robustness against the variations in image orientation and composition. Model Model configuring the effectiveness efficient net within pre-processing. The effective net B0 model recognizes for its balance between the performance and computational efficiency. It is adopted for this task. The pre-trained efficient net B0 is fully connected layer is replaced with a linear layer tailored for the binary classification. Transforming the learning is utilized by initializing the model with the pre-trained weights enabling the faster generalization. Training, which trains with a k-fold validation. A stratified k-fold approach is used to evaluate and improve the model robustness. Test time authentication. Authenticate and predict. Test, test time authentication, which is a multiple authenticated version of a test images are passed through the model and their predictions are averaged to enhance the accuracy and reliability. Evaluation, accuracy, F1 and AUC. Evaluation metrics. Performance is measured using the accuracy, F1 score, prediction, recall, and area under the ROC curve AUC. Here comes result and discussion. The proposed deep learning framework based on the efficient net B0 architecture demonstrated the high accuracy in detecting blindness caused by the diabetic retinopathy. The model was tested on the UPTOPS 2019 blindness detection dataset and achieved accuracy will be 94%, F1 will be 92%, prediction will be 91%, recall will be 93%, AUC ROC will be 95%. The key enhancements that contribute to the model performance are pre-processing techniques, image cropping, Gaussian blurring, resizing, improved image clarity. Data authentication, random rotations, flips increases the robustness. Transform learning with efficient net B0 accelerated the training and improved generalization. Test time authentication, which enhances the prediction reliability. The study highlights the potential of an AI-powered systems in early detection and prevention of blindness. The effective net B0 model efficiently classified retinal images while maintaining a balance between computational efficiency and accuracy. The last we are going to see about the conclusion and future enhancement. In conclusion, the finding from the proposed deep learning framework for blindness detection highlights its strong performance and reliability. The model demonstrated expectational result in key metrics such as accuracy, F1 score, precision, and recall, and AUC ROC, confirming its ability to accurately classify the retinal images and predict blindness outcomes. The high F1 score underscores the model's effectiveness in balancing the precision and recall, which is a crucial for minimizing the misclassification in medical applications. While involved image cropping, Gaussian blurring, and resizing was integral in improving the image quality and enabling more efficient feature extraction. The uses of data authentication techniques like random rotation, horizontal flips enhance the model's capacity to generalize and adapt to the variation in the image orientation. The incorporation of a transfer learning with pre-trained efficient net B0 weights as a significant boosted accuracy, particularly with limited training data. And test time authentication, which is an TTA, further increases the prediction stability by averaging the result across the accumulated test images. In comparison to the baseline models, the proposed framework showed the significant improvements in both accuracy and robustness, positioning it is as a promising solution for the automated blindness detection. These results demonstrated the framework's potential for real-world ethical applications, clinical applications, providing an effective and dependable tool for timely and accurate diagnosis in medical imaging. imaging. Thank you.